Hey everybody, welcome to part two of the muscular system. Today we are just going to finish off by talking about the system a little more in depth, plus some problems that can occur with it. So we will go ahead and get started. As always, if you would, please like and subscribe to the video if you haven't already, or to the channel rather. It really helps me out. I appreciate it, and it goes a long way, and it's free. So here we go. Let's talk about the muscular system. So let's talk about the anatomy of a muscle. Um, if you've ever seen nesting dolls, okay, very popular in Russia. They're called Russian nesting dolls, and they're little tiny dolls. And then the little tiny one fits inside a bigger one, fits inside a bigger one, so on and so forth until it's a large doll, right? It's kind of how the muscle is. If you look here at this diagram, you will notice the muscle fiber here, and this is, of course, tiny, tiny, that is wrapped in what we call an endomysium. There are a whole bunch of those little, I know they look like straws, but little muscle fibers that if you gather them all together and wrap them in what we call a paramecium, okay? Endo, of course, meaning inner. MYS, always muscle. Peri means around, okay? Um, and group a bunch of those together, wrap them in a paramecium. Then we have what's called a fascicle. Then, if we group a bunch of fascicles together and wrap them in an epimecium, which means above or out, then we have a muscle bundle, or the muscle itself. So it basically starts out like the dolls, right? Tiny, get them together inside of something larger, together inside of something larger, and you have a muscle, okay? Um, in between the fascicles, you'll notice also that you have blood vessels, and this is what brings blood to the muscle to keep it nourished and alive. Here in this particular diagram, it also shows the tendon attaching to the bone. Tendons attach muscle to bone, whereas ligaments attach bone to bone, which we talked about in the skeletal video. If you haven't watched that, check it out. But the tendon really is just an extension of the muscle. So that's what that is portraying in this particular diagram. Okay, so let's talk about the parts of the muscle fiber. So right here, if we go back, is literally this. Okay, just magnified. So parts of the muscle fiber include kind of the same setup, smaller wrapped into larger. The outside of the muscle fiber, or the muscle cell, if you want to call it that, is what's called a sarcolemma. And it keeps basically all of the myofibrils, or the very tiny bits of the muscle fiber, together. Because it is a cell, inside each has also a nucleus, and the nucleus is a control center, basically, of the cell. Um, all cells, well, okay, not all cells, but a good majority of cells have a plasma inside, basically, a sometimes gel-like, sometimes thinner, um, and in just a basic generalized cell, they call it cytoplasm. Okay. Well, in a muscle fiber, we call it sarcoplasm. Sarcoplasm, because it is inside the membrane, or the wrapping, that is called a sarcolemma, so it's called sarcoplasm. Okay. Inside of there are these thread-like projections, that are called myofibrils. Okay, myo because of muscle. Um, these contain the element that allows for contraction of the muscle, which we'll get into here in just a moment, because we're going to break this part down even further. In between or inside of those is myofilament, and we have thick myofilament and thin myofilament, each containing different proteins. One contains actin and troponin and tropomecium, and the other just contains myosin. Okay. Um, so those you'll see here in a moment play a good part. And here is what that is. So this is just representative of this. Okay, we're just going smaller and smaller. All right. So here you have basically what boils down to filaments that slide. Okay. Um, this is what is called a sarcomere. Okay. And then there's these little kind of zigzag lines that they call Z lines. And when a muscle needs to contract, what happens is a series of, I don't want to call them reactions really, but just a series of actions take place where those Z lines, so you have them here, you have them here, become attracted to one another, and so they go towards each other, thereby contracting the muscle fiber. And when all of them do that, the whole muscle contracts. Okay. Oop. Let's go back here just a moment. And then the thin and the thick filaments are basically what decide whether or not they're attracted to one another, so to speak. Okay. And again, that has to do with actin and myosin or myosin. Myosin and actin really like each other, and they do want to get together if they're attracted. However, it does take that series of actions to occur before the cells will kind of open up and go, all right, you guys can hang out together. And they attract towards one another. And because they are part of those Z lines, as soon as that attraction occurs, the Z lines pull together and you have a contraction or a shortening of the muscle fiber, and therefore the muscle contracts. We also have what's called neuromuscular interaction. And neuromuscular interaction has to do with action potential. I will be doing a video on the nervous system, but what action potential really is, and I'm sure you've heard this somewhere along the lines in some type of like biology class or something like that. What action potential really is just the nerve stimulating something. It's a when the body needs to do something, it sends out electrical impulses, nerve impulses, right? To the areas that need them. And then those impulses create an environment where neurotransmitters, which are basically just chemicals, can come be expelled from the axon of the nerve cell, which is the bottom part of the nerve cell. And hopefully this is all happening in the right place near receptors that are receptors for those particular neurotransmitters. Okay. Neurotransmitters and receptors are kind of like a lock and key mechanism. If a neurotransmitter is expelled or released, and it hits a receptor that was not meant for those neurotransmitters, nothing happens. Okay. But if it hits a receptor that was meant for those neurotransmitters, then that impulse or that action potential is then relayed to whatever the receptors are on. In this case, it would be muscle fibers, and an action is taken, whether it be contraction of a muscle. This happens for us to blink. I mean, anything you can think of, really. So here is where that whole neuromuscular junction occurs, right? So you have the muscle here, you have the receptors that are just waiting for these particular neurotransmitters to come to tell that muscle to do something. Most of the time it's to contract, okay, because contraction produces movement. And these little vesicles contain those neurotransmitters in the end of the axon. The axon, again, is the long, in most cases, long part of the nerve cell where these action potentials kind of are sent out, okay? Once those vesicles come out of the end of the axon and release all of those neurotransmitters find their receptors, as you can see right here. I hope that's big enough for you to see. They fit together beautifully like a lock and key, and that action potential is relayed to the muscle, and the muscle then reacts however it is intended to react at that point. So that whole area between muscle, receptor, and axon from the nerve cell is known as the neuromuscular interaction and the neuromuscular junction. There's various disorders of the muscular system. These are just a few of probably the more common type that you would see if you worked in, possibly for the majority of these, it's probably going to be more pain and spine offices, possibly neurology, depending on what the source of these issues are, where you see more like injury type muscular issues like sprains and strains and things like that. You're going to see in orthopedics. But various disorders of the muscular system, based on where they originate from, usually you're going to see more with like neurology or, like I said, pain and spine management. So just kind of to run through these really quickly. Fibrosis. Fibrosis is any abnormal increase in connective tissue in the muscle, and that causes the muscles to just be larger than they need to be. And I don't mean large in like a good way, more dense, more thick, and it's harder for them to move. Muscular dystrophy is a muscular disorder that causes degeneration of the muscles. Strain is when the muscles are stretched excessively. Myasthenia gravis is a disorder that causes extreme muscle weakness. It is an autoimmune disorder, meaning that the body is actually attacking itself. And it can lead to improper neuromuscular function. Tetanus is caused by bacteria. We think of tetanus always, rusty nails always come to mind first. But it is the bacteria that comes off the rusty nail if you step on it that can cause tetanus. And what it does is basically causes continuous stimuli to the muscles. And if stimuli is continuous like that, just kind of over and over and over, it can cause spasms. It can cause lockjaw where you can't open your mouth because these muscles lock up. So always being, of course, current on your tetanus shots is good, or getting one immediately if you are exposed to any type of bacteria like that. Fibromyalgia is a condition of muscle and joint pain, widespread, usually muscle and joint pain, and there's really no known cause for it. Um, Fibromyalgia is still, in the grand scheme of things, a fairly new disorder. And by new, I mean not like in the last year, probably 25, 30 years. So it hasn't been around forever. So there's still really not a known cause for it. Poliomyelitis is polio. Most people know it just as polio, which is caused by a virus. So it is a viral disease that destroys motor neurons and can also lead to paralysis. We've had a polio vaccine, at least in this country, for many, many, many decades. I had it when I was a child, and so we don't really see a whole lot of polio cases anymore, luckily. Botulism. Botulism is a poisoning by a toxin that actually blocks acetylcholine, which is helpful for motor neurons to function. And if it blocks that, then the motor neurons cannot function and you'll see paralysis. Botox is actually made from botulism, um, from the toxin, and that's why they use it to deal with like lines and wrinkles because it actually blocks the acetylcholine, the ACH from the muscles, the motor neurons up here, so it like paralyzes the area. It's also been more recently used to help with migraine headaches, and that's been fairly successful from what I understand. All right, so thank you once again for watching. I hope to see you again soon with another exciting anatomy and physiology video, and I will see you then. Take care and have a good day. Bye bye.